And then all of these little colored dots are neural crest cells. So they're arising dorsal to the neural tube all along the anterior posterior axis. And then as time goes by, they leave that and they go down and colonize just everywhere around the head up here, into the facial structures, the neck structures, all of these cells up in the cranial region. And there's some order to this. They're not just totally randomly migrating everywhere, but they're kind of going a concomitant based on their anterior posterior localization. And there are many different kinds of structures in the head that are arising about this time and that the neural crest cells could potentially contribute to. And here are just some examples of this. So many of these are sort of things that relate to bones, and neural crest cells do contribute a lot to the bones of the skull and the jaw and the neck. In addition, here's the small bones of the ear that we mentioned before. So inside of the ear, there are a few different really small bones that are important for the ability to hear. And these need to be formed from neural crest cells in order to have the ability to detect sound. Then here are three different glands: thymus, thyroid, and parathyroid. These are all developing in sort of the neck area, and they all have neural crest contribution in order to arise. Okay. Then a little bit about bone development. So one of the ways of forming bone is to do this starting out with neural crest cells. And this method or approach of bone formation is known as intramembranous ossification. So the intermembranous part is the neural crest part, and then the ossification just means the creation of bone cells, or creation of bone. And so what we start out here is with some mesenchymal cells, so some cells in a loose configuration. They're derived from neural crest, and they're going to go directly into forming bone without making cartilage intermediate. So when we get to it in mesoderm, in the story of mesoderm, we'll talk about a different type of bone formation paradigm that involves just mesoderm cells making cartilage and then turning that cartilage into bone. But by this method, we skip that cartilage step and we just go right to bone. So the basic steps are that we'll start out with a neural crest mesenchymal cell, fairly generic at this point, present at the right time and place. These cells continue to proliferate, they change their shape, and they give rise to then an osteoblast, which could be considered a committed bone precursor. So blast, you'll often see that phrase for a precursor cell. Osteo is a phrase that you'll often see for bone formation. So these are the committed bone precursor cells. And even though they're still in a fairly relatively undifferentiated state, they are starting to do certain bone-like things. And this includes secreting this matrix outside of the plasma membrane that calcium will bind to. So there becomes this process of more and more calcium getting incorporated into the matrix around these cells, and it begins to start that hardening or rigidity of the area that then gradually grows and will eventually become bone. So once these osteoblasts become surrounded and in fact just basically embedded in this whole matrix, they continue their differentiation, and we now give them a new name, osteocytes, and these are cells that are involved in making the bone. So eventually these masses of osteocytes plus matrix will expand into small slivers called spicules. And so here's an example of this in the chick head region. Initially you can find all these dark staining little slivers of future bone tissue, and as time goes by they get more elaborate and thicker and more connected to each other, and that ends up forming the bone in this chick place. So finally they're going to be calcified bone with a lot of calcium integrated within this matrix. Okay, any questions on this? All All right, let's go ahead and take a break. Come back at